us where the International Space Station is, Hubble, etc.?
Okay. So if the Earth were actually this size, the International Space Station would be orbiting about a half an inch above the surface. And that dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, you know, I don't. It's fine. He wants to. I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide-angle lens, which curves horizontal lines. Right. So in the photo, you see this curvature of Earth's surface, and he said, "Wow, he's in space. Look at that." No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
24 miles high is the height Felix Baumgartner was at when he did the Red Bull space jump. At 24 miles, they have to fake the curvature in order to give you guys something to marvel at. This footage you're looking at right here is an amateur high altitude balloon, 24 miles high, okay? That's 4 times the height of a commercial aircraft. You don't see any curve, and yet we have people that claim they've seen the curve and they've never been higher than a commercial aircraft. Learn what indoctrination is. One of the symptoms of indoctrination is to lie to yourself so as not to disrupt or shatter your belief system, no matter how ridiculous it may be.
What up, fam? We're back at it with a fun one that completely dunks on the globe, that being plane surveying. Here's the definition for plane surveying. Ordinary field and topographical surveying in which the curvature of the Earth is disregarded. So when we do any sort of engineering, we always use plane surveying. We never use geodetic whatsoever. So even though it's allegedly curving, we're going to assume it's always flat to engineer. You have to assume the Earth is a plane to build buildings, runways, railroads, bridges, but you guys think the Earth is curving. Remember, we use plane surveying for engineering up to 100 square miles. Here's our Earth curve calculator. Look how much curvature there would be at 100 miles. But you guys completely disregard that. So if what we're using to build must be true, or we wouldn't be able to build things, then that means the Earth is flat. Trust me, bro, it's there, but to build things, we're gonna disregard it.
You don't need to believe we live on a flat, stationary Earth. But you do have to believe that the Earth is a spinning space ball. One is observable, and the other is in your imagination. What do your senses tell you when watching this footage? That they are telling you that this is a ball and you can see curvature. You need to see a doctor because you're suffering from severe cognitive dissonance. I know what we can do. Let's ask some pilots what they think the shape of our Earth is.
Flat or is it globe, mate?
It's flat.
This is flat. Thank you very much, mate. God bless.
A man asked the pilot if the Earth is flat.
Can I talk to the pilot, please?
Right here.
You're the pilot?
Hi.
How long have you been flying for?
For Delta, 21 years, but maybe like 30 something.
I want to know, because they say the pilots know a lot. Do you think the Earth is flat or no?
I know it's flat.
You know it's flat? How long have you been flying for, you said?
Over 30 years.
And when you tell people that, do they think you're like crazy or no?
Only one person.
Only one person?
Yeah.
They built it for a flat, stationary Earth. And my goal is for some young fighter pilot to listen to what I just said, go out tomorrow and set the bottom of your L strobe on your altitude, run it out there to 80 miles, and that bottom altitude on your cursor will stay the same.
Are you a pilot?
Yes, sir.
One question.
Okay.
When you descend in the air,
Yeah.
do you dip or do you go straight?
It's straight.
Straight?
A little more with the nose up. That's it.
But straight. You don't dip
Yeah.
into the...
No.
Okay, thank you so much. I appreciate
You're
you.
welcome, sir. All
Have
right.
a great day.
Did you notice any curvature while we were up there?
Curvature? No.
No? There's no curvature?
It's just all flat.
The pilot, is the Earth flat or round?
Flat.
Thanks. I'm with you.
Pregunta controversial. Hay un debate ahora en YouTube especialmente en el que
Las personas se cuestionan que si la curvatura de la Tierra es observable o no es observable. No, a las alturas que vuelan esos aviones, usted no va haciendo ningún ajuste, va como si fuera parejito, sí, sobre terreno. No, pero sí tiene unos 2 grados más alto que normal, depende de lo que del peso del avión. Ah, ok, la nariz va hacia arriba. Sí. Pero no tienen que buscar la curvatura, no vuelan como si fuera sobre un plano. Sí, es lo que trata de hacer el avión. Bueno, muchas gracias. Mucho gusto. Okay. Siga bien. Hasta luego.
Because they tell us, that at least in the U.S., the ground's moving at about 700 miles an hour left to right. And I was thinking that's kind of odd if you're landing, going north, or moving in the north direction.
That's not, no, the ground looks to us like it's standing still.
Yeah, not an issue, huh?
Yeah, no. You could probably see the Rockies from Kansas.
Wow.
It's a clear day, but if it's smoky or hazy, obviously you can't see.
Excuse me, guys. Hey. I have a question for you.
Yeah. One of us can answer it.
Hey. You guys adjust for curvature as you're flying through the air. The Earth is supposed to be a ball, right?
Yeah.
So should we be dipping down the nose of the plane to compensate for the curvature, or do you guys just, or do you fly on over a flat plane?
Well, we're about a millimeter over a bowling ball. We're not that high.
8 inches per mile squared is the official story of what the curvature drop should be. So a distance that far. If you're 8 inches from the shore on a beach and your friend is rowing his boat out 1 mile away, the boat should be already hidden by the curvature. You guys don't see you see horizon at eye level.
No, I mean, if you look at more of a just curvature of the Earth, we're on the perpendicular, we're just on that tangent.
So
and
really,
that never changes.
Earth's flat.
Sorry?
Earth is flat.
Yeah, we know that. We've seen it every day.
Flat and stationary.
Exactly. Everybody else.
Well, you know that. You guys see the horizon at eye level, and you have to understand that if you're on a ball, as you rise from a ball, you would have to look down to see the horizon.
Yeah.
You don't ever see that. I look out the window of a plane, and I see horizon as far as I can see, flat.
What's different from the front?
Even from there. Your windows aren't that much different. Earth is flat. It's a big lie. You guys should look into it. You know it's flat. You guys fly over it every day. I know.
Do you say it's flat?
Yes.
Yeah? Thank you very much.
Whenever you fly your plane, do you ever account for a curvature?
No.
Do you ever account for Coriolis or Earth spin?
No.
Do you ever see the Earth curving?
No.
Does water find its level?
Yes.
Does it always find its level?
Yes.
Okay, so water always finds its level. Does water conform to its container?
Yes.
Y luego, además, aquí aparece como si fuera, no sé cómo le llamamos a esto, un anexo, un añadido, algo que se cose.
Sí, exactamente, un parchecito, que me recuerda a una persona muy especial. Plana y estacionaria, ¿se ve?
¿Plana? Sí. ¿Y no tiene algo de achatamiento? ¿No se ve no? Eso es cuando ya nos vamos a la órbita, ¿no?
La curvatura se ve cuando la cámara es de ojo de pez, como la que llevaba el que se tiró de Red Bull.
Sí.
Ahí sí que ves la curvatura, pero si la cámara es una cámara normal, se ve todo recto. Normalmente volamos a lo máximo, el techo del avión es 41.000 pies, que son 12 kilómetros, 800 metros o algo así. Sí. Pero normalmente volamos a 35, 37, que son
altura no se ve
10.
La curvatura.
No, hombre, no, según... a ver, yo he volado con el IER a 47.000 pies, con el IER del jet privado, que son unos 13 kilómetros, 600 o algo así, y tampoco.
Did you notice any curvature while we were up there?
No.
No? What did you see while we were up there?
Just the blue sky, white clouds.
Yeah, is it flat or?
Pretty flat.
Pretty flat?
Yeah.
Okay, thank you.
Captain, someone wants to say hi, is that okay?
Oh.
Do you adjust for curvature when you get up to a certain altitude?
Well, yeah, when you see the sun coming up on the horizon, then you will.
But the plane stays at an even pitch throughout the whole flight?
Yeah.
So, I mean, not too much curvature to account for?
No.
More flat than anything?
Nope, you close your eyes, you won't have a clue.
True. More flat than anything?
What was that?
It's more flat than anything.
Yeah.
Oh, yeah.
Thank you, guys. I appreciate it. Thank you.
Flat or a ball?
Flat. What's a ball? I think it's flat.
Yeah, me too.
Pretty flat to me.
It certainly does, doesn't it? And you've got that flight in.
Excuse me, do you mind?
Hey, how you doing?
Very well, how are you? So, you know how we just took a flight of descent?
Yeah.
Did you have to compensate for curvature?
Yeah.
So, did you just have to compensate for curvature due to the flight of descent as we landed just now?
No, not necessarily. Yeah.
All right, thank you so much. So the pilot just told me that the Earth is flat.
Hey, I just want to say thanks for the smooth flight.
All right.
I did have one question. Is there like a specific angle of downward tilt you have to fly at?
3 degrees.
3 degrees for the curvature of the Earth?
Oh, for the Earth?
Because,
we just fly over the troposphere.
Really?
Yeah,
But
yeah.
do you have to keep like kind of going down because...
No, we actually have to nose up. It flies, yeah.
Really? Because I was reading some stuff on the flat Earth that made a lot of sense. Have you looked into it?
Which one?
I was reading a lot of stuff on the flat Earth.
Okay, yeah. True.
It's true?
Yeah.
Okay,
Yeah.
all right, cool.
All right.
God bless, brother.
All right, have a good one.
You too.
I'm a fellow, Casey Josh, I'm a fellow just PPL, pilot,
Cool.
yeah.
Yeah, nice.
I've got a couple of serious questions to ask you.
Okay, here we go.
Yeah, there's a big time. Curvature.
Curvature?
Yeah.
Yep.
We don't allow for curvature, do we?
For anything, not for you usually.
No, we're round, we're a disc, aren't we? Round and flat.
Yeah.
Sorry. Hey, look, honestly, quite seriously,
Yeah.
we are, aren't we?
Yeah.
First, wait until the sun has half disappeared beneath the horizon, so that you can only see the top half, and are satisfied that the bottom half is no longer visible. Next, using a camera with adequate magnification capability, by zooming into the half-set sun, you will be able to bring the entire sun back into full view. Then, as you zoom in and out, the sun will appear to rise above and sink below the horizon, often with a significant portion of sky reappearing beneath the sun, proving beyond any shadow of doubt that the sun is simply moving away from your position and not physically falling beneath the curvature of a globe. Heliocentrists would have you believe the very opposite of what every human who has ever walked the earth has seen with their own eyes. It is obvious to any child and sovereign-minded adult that the sun, moon, stars, and planets, every light in the sky above, revolves over and around the motionless earth beneath our feet.
Imagine a table 2 meters wide in a completely dark room, and you're holding a small but very bright light bulb, 3.4 millimeters across, and you were holding it about 31 centimeters above the table. What you'd see is a circular pool of light directly on the table, beneath the light bulb. But on the other side of the table, it would be in darkness. Now, it seems to our mind that if you were on the other side of the table, you would see the light because it's, above the table. But that's not true, because on that part of the table, it's in darkness, meaning that the light isn't physically reaching that part of the tabletop.
Your senses are correct.
We're also told that the sun sets because as the Earth rotates us away from the sun, it's actually obscured by the physical curvature of the Earth. That's not what we see.
What we see is a local sun that is taking its local light with it. What happened to the horizon glowing across half of the world? Most sunsets are already fading through pollution, dander, chemtrails, and fog. Plus, refraction will always make the sun seem like it's going down, as well as your perspective.
It would appear to sink down in your field of view. That's perspective. The further away you get from it, the lower it will appear. It doesn't physically change its height, it just appears that way to your eyes, until eventually it will disappear behind the horizon formed by your eye's vanishing point. Your eye has an angular resolution of 0.2 degrees, and anything at that height will disappear beyond the limit of your sight. Many times we can see time-lapse footage of the sun that shows it getting smaller as it moves away from us. Now, that's not always the case, since the sun is travelling around the North Pole. The closer you are to the north, the less you'll see the size change. But from locations beyond the equator, you'll absolutely see the sun's size change. And that could never ever happen if the sun was 93 million miles away. You wouldn't see the sun change at all.
Our eyes cannot see farther than what they were designed to see. but that is no reason to keep them closed.
There's also an effect that occurs under certain conditions called atmospheric lensing, where the sheer amount of atmosphere, as well as the rain between you and the sun, acts like a lens and a prism, magnifying it greatly, which leads to another observational proof that the sun setting is an optical effect.